Hey everyone, Anthony here. I'm looking a bit tired because I'm now on take 12. So I have a beer. And let's see if we can talk about knob change callbacks. In fact, this is actually a really interesting topic and a viewer request to look at like how you can slow down Nuke, not intentionally but accidentally. So we're going to look at callbacks in this particular context. So we'll start out quickly with our rig here. It's you know what, we won't even use the viewer. Got a grade node and the properties bin up, and we're going to look at the knob change callback, which is a knob. So for those of you who remember the previous video, you would have seen me do something like this, Nuke callbacks. So on the Nuke callbacks list, there's a whole bunch of them here. We do have a knob changed callback. This knob change callback is actually registering the callback for the entire of the Nuke session, right? Which is great if you want to do that. What we want to do is we actually want to register it on the grade node itself here. So that way, if we copy and paste this guy around, it sticks to this grade node. It doesn't stick to all grade nodes, okay? Because you can add knob change here and you can just say for all grade nodes, please do something. And then you can have code that says, oh, but not for this grade node, not for that grade node, like that gets a bit more complex. So it depends on how you want to solve the problem. In our case, we just want it for this one grade node. Right? So we already know it's a knob. Now, as a brief refresher, if you look at this here and you try pick the knob, you might just go, oh, I'll pick it and I'll edit it. No go. It's not a visible knob here. All right, so we actually have to look a bit deeper. Let's do this. Nuke.selected node the grade. All right, we'll just comment that out. Oh my god. Let me just come back in a second. Okay, so what happened was they're fixing it in Nuke 13.0 v3, I believe. If you have no lines below the bottom one, just always have that one, and you select this and comment it, it locks up Nuke. Oh, yeah, it's so annoying. Right. Okay, back to where we were. Which is why you always see me have a huge amount of lines in the script editor, because I've been bitten by that so often. Anyway, right. So, first of all, it's a knob. You won't see it, so we just need to go and edit it. So, knob. The knob is called knob chain. Oh my god. You can tell the fatigue is coming up after 11 takes of this. It's a Python knob object. The Python knob object is just a text. It's like a text knob. You just can't see it, and it holds text. Right. So we manipulate using set value and the usual kind of stuff. Set value. Right, and you can just do stuff here like a print. Ooh. All right. So this is almost your hello world kind of setup. Right, and you can see something came out here because changing the setting the knob change, setting a different value is a knob change event. All right, so let's just clear that out. I'll show you how I actually think you should do this. Just bring my rig up, cool, make it a bit easier. So I'm just going to do this because it's text. I'm going to use this triple quoted string approach I mentioned a bit earlier, because I can just type a lot faster. Maybe not as accurately, but I can type a lot faster and just use new lines and stuff. Right, so we're going to want to print out, I don't know, import date time, print hello. Hello, that'll work. Date time dot date time dot now. Okay. Yep, that's good. Set that up. Great. So you can see hello. Clear that. If I change a value here, that makes sense. I'm just changing one value and it updates. Cool. You know, I tick black clamp, white clamp. Any knob change does what you expect. Right, so perfect. No issues whatsoever. Move my head away. But also, if you're the inquisitive type, you're going to go, hey, what happens if someone grabs a knob and swings it? Every time it changes, it's more around every time this number or something updates, you have a chance for it to go, ooh, the knob has changed. So your code can potentially run a huge amount of times. As you can see, it just keeps going and going and going, right? Just it's a lot of stuff going on. So that's the first thing. When you're dragging sliders around, there's a lot of knob change activity. Second thing is that you may not realize everything that could be a knob. So we've covered things like these obvious things, like, you know, the ones you touch are clearly knobs. Okay, if you crunch and open, that is a knob. That's a knob that's changing state. All right, so that's a bit of a gotcha. But again, this doesn't seem too bad. You can't cause this level of horror. Well, what happens if I did this? Clear this to make it super obvious. Every time you select and deselect, it's a knob. This should become pretty obvious to you what is and isn't a knob, because obviously when you do the node selection status, you set the selected knob to be true or false, right? So that's kind of an obvious one. We haven't done much node graph manipulation in terms of drawing with nodes. It's fun, but not that useful. Well, not the thing I'm thinking of. But XY position is also a set of knobs. So you can see that is just going mad. And you can actually also see, even on the video, it's a little bit laggy. So let's just stop printing everything. Update the code. That's not laggy. That grade node is not lagging where my mouse cursor is. So you can actually see the cost of print statements here, because it's got to draw and update the display here, right? So that's the first thing to consider. Every time you have a knob change callback, it can run a shed load. So to demonstrate what we can do, the first thing is always guard this thing, right? And by guard, I mean, well, bullshit. So in multiply, we're going to set it so that there's a callback that says, hey, if your multiply is greater than 1.2, it's too hot, and we'll just chuck a label on there. It's not particularly pretty, but it'll illustrate the concept. So we don't need that. So we're going to do this. Nuke.thisKnob. Actually, we're going to do nuke. We'll do it the simple way first. This node. Let's nuke this node. All right. If this node node.knob multiply is the value. If the value is greater than 1.2, right, then we're going to set the this node knob label set value to be too hot, right? Else we're just going to clear it and just make it, it's okay. Obviously don't do this to your artist, because this is actually deleting anything they put on their label, but for our purposes, perfectly fine. All right, let's clear that one. Most likely this is what you're going to have happen. You're going to do this and go, hey, callback, looking fine, not an issue. You'll publish it out and people will start using it, and no issues will occur. But from what we know earlier, this code is constantly running. Even if I do this, it's running. So we know that we only care about the multiply knob, right? So we need to add a guard in here and say, hey, if someone's swinging the lift around, we don't care. If someone's changing the Y point, we don't care. We shouldn't be running this code. So we can actually do literally what we just said. Just nuke this knob. In the context of a knob change callback, I believe in a couple other places, but this is the first thing that comes to mind. There is also this knob, which is exactly the same as this node. This node is, what node am I running on? For a knob change callback, this knob is, hey, what knob are you running on? So we can use that, and we can say, this is our guard here. If this knob.name equals multiply, then do some work. Right, so let's do that. So if it's multiply, it's still going to do the same work. But we know from previous experience that it's not going to be firing on this. Well, more accurately, it's not going to be running this code. It's going to be running this, and it's going to be running these two lines, but it's not going to be doing this stuff, which is potentially more expensive. Right? So that's the idea of a guard. I would generally encourage you to do that just out of habits. Like there should be no reason to not do it. If you're worried, or if you're not worried, if you're wondering how to do this in general, for maybe you've got something which you want to look at, say the multiply and the gain. If you multiply them together, or if you do some calculations, if your gamma's over a certain number and your multiply is down, you tell them it's becoming too crunchy, or you know, some combination. You simply do something like this. That's all I've done here. I've said, if this knob is in the multiply or y, if it's one of these two things, then do this work. Great. So the guard is now, it's permissive, restrictive. I don't know the word I'm thinking of. It's basically explicit. It's saying if it's one of these two knobs, then do the expensive stuff. You can imagine how painful this would be if you're at a facility and you're, say, I don't know, querying shotgun, right? So for example, you might have a button somewhere on a user thing that says live link to shotgun, and if you don't protect it carefully, let's say shotgun has a lookup table. I don't know why you'd do this, but let's say you do. You could be constantly hammering shotgun for information, and you know, shotgun's not going to like you. Not only is it not going to like you, it's going to be slow as a dog. So by protecting it like this, you can have more control about what's going on. Also, other areas, I'll deliberately put a print back in here. I'll actually deliberately uncomment those and shove this code on. These are other things that you may not realize. So labels. Every keystroke is a knob change event, right? Node name, that's fine until you press enter. So node name is a, like, it doesn't do per keystroke. Label does do per keystroke. If you put certain custom knobs on, some of them will be per keystroke, some of them will be for the whole thing. You can experiment and find out. But by having this if knob name in blah, you'll be able to, by being explicit, you'll basically be able to dodge anything that you didn't realize. Like, I don't know how many people know that this is a knob that triggers off knob change. So yeah, that is, I guess, the core of it. Now, I'll demonstrate a couple other things since we're here. I'm going to get rid of that and make it so it doesn't spam so much. Wow, that's really horrible looking, isn't it? Okay, so that knob change callback is on that. So if I copy paste this knob, this node, obviously if I swing my multiply, it will do it. So that's good. If I put down a new grade node, obviously it's not going to do it. So that's fine. So we know that this this code we have is following this. Problem is that we now have two copies of it. So if on the grade, what is the grade? I think this, yeah, we'll find out. Yes, okay. So this node here now has a different copy of the code because I put it that way. So that is one thing to look out for. What you probably want to do is you probably want to run a function for this, and that's what I referred to as writing, I guess, better knob change callbacks. So we'll take this guy here. How are we going to do this? Okay, so delete him. This is label's horrible and the name is horrible. Let's just make it not look like a, yeah, okay, that's much prettier. So let's take the whole thing out of here, right? And we'll just define our function. Def do some warnings. Okay, this is the naive, straightforward way to do it, right? So we have do some warnings, and then it's just do some warnings. This will work fine, by the way. So we define the function. Python in this Nuke session is now aware of this function. It goes, right, I have a function called do some warnings. We've assigned it to the grade node. Let's go, all right, cool. The grade node will now warn with this to has that thing. So if I bring it up to here, right, perfect. This is now working. Copy, paste, and this is also now working. If we discover that this is too cryptic for an artist and we wanted to just change it to the old-fashioned, too hot, right? I am now updating this function. I am not updating either of these two nodes. Also notice the message hasn't changed, even though that I've updated the message. It will update now, right? So that's another way we can see we're protected. We haven't done the expensive stuff. This node here as well, now working, because both of these are referencing the same common function. They will both read it, so you'll be able to change it in one place. This has some advantages and disadvantages. If I copied this one and sent it to somebody, they would also need a copy of this function, but obviously you'd need to know to send it to them as well. And this is the point where you would stuff this kind of thing in your I guess your init.py, or you'd have a facility where it would help you out with this kind of thing. There are pros and cons to both approaches, but just so you know, this is nicer and easier, especially if you're a single artist. This is much nicer to work like this. All right, but going into TD-ish kind of land, if you wrote this function here, this is quite naive, and I wouldn't write it like this, because if I have this grade node here, and I also want the same behavior, my only option is to actually install the callback on this node. So it'd be, instead of the grade, it'd be Nuke2Node grade 3, right? So I'd now have installed the callback to here, grade 2. Let's put another grade down, grade 4. But maybe the grade 4, I just want to run a process over all my grade nodes, and I just want to say, all right, for all the grade nodes, my logic is perfect. I calculate everything I want. Just tell me which ones are problematic. Just put the message on there. I don't want the callback. I don't want that weight on it. Okay, fine. This cannot work because we've written in a way that says this node and this knob. So the pattern I would suggest is something more like this. I'll copy, comment, and then paste it in copy here. So what you want to do generally with this is you want to feed it with something. You want the option to say, hey, run on this node and this knob if you can. The use of none value is important. So I'm saying by default, it's not running on a node and it's not running on a knob. And then we go here saying this node is the node. I'm just going to change it to the just so it reads a little bit better. So this, from the point of view of the functions, this node is the node that you supplied me, or if you didn't give me anything, if you gave me the none value, if you just left it blank, it's this node, as in the one that Nuke is going to tell me. And the same thing occurs to the knob. So this knob is knob, or what Nuke is telling me, right? So that's the only change I've made to this function, and we'll just put some more stuff here. So I'll just redefine the function, and we'll just make sure that this toHostStat thing comes up here. Right. So this function, nothing has changed. This is still running fine because when we have the code here, it says do some warnings. We don't tell it what the node is, and we don't tell it what the knob is. And so it just goes, oh, okay, well, if you haven't told me the knob or the node, I'm just gonna ask Nuke. You didn't help me out here. Nuke is my friend. So then it'll just get that fine. But for this grade 4, let's set this to be too hot again. So whatever number it is. So that grade 4, we can just run this function like this. Do some warning on Nuke2Node grade 4. And because of the way we've written it, we have to provide a knob, because Nuke this knob, the way you run it this way, will be a little bit strange. I'm not going to complicate. I'll show you how to make this a little bit better, a bit swankier in a second. Okay. Right. So our function now, if we feed it correctly, we can just run it on anything. So even here, oh no, sorry, this one here, grade 4. So I've just shoved it back down. There is no callback, so it was at some point too hot. let's just redefine that. But because our function's being written in a way, we can just say, hey, can you please just check a whole bunch of nodes? Oh, that's fine. And that is a much nicer way of writing these functions. It's not a lot of change. You don't need to do a huge amount of work. Just always allow, think in terms of this code does something to a node and it may need a knob, right? So that is a design decision you'll have to make. But don't make it so constrained that it must always run with this node and this knob. Allow yourself the luxury of taking your code and just saying, it's not a callback today, just please run this function on this node, right? And this is this pattern here. Using this, this node equals something, or give it Nuke this node. You'll see this kind of idea in a couple other places, but for a knobChanged callback, this is super useful because you're going to do a lot of work to make the knobChanged callback do something pretty clever, I'm guessing. But you don't always want to run it constantly. Like, for example, you could quite easily not have any callbacks occurring. You could just have like imagine you took a script and you just have a button on the shelf here saying, hey, if you click the button, sanitize all my nodes. You could have as a callback. You could just have as a function. Why not write a function that allows you to do both? So yeah, that's a very, again, with callbacks, super brief dive into some of this stuff. I'm hoping you'll find this kind of pattern a bit more useful. I did mention I was going to make this a bit more clever, so you can turn your brain off at this point. But what I've done by this design here is I've written this explicitly as a callback style function. So I'm using a guard for the knob. In this case, I've defined it as if I don't provide a knob, Nuke is going to say, oh, I'm going to in the function go, this knob is the knob you provided me, which is nothing, or whatever Nuke tells me the knob is. And obviously, since we're running it here in the script editor, the knob is going to be nothing. There is no knob context, but the rest of my code actually requires the knob. So we can actually make it less sensitive to that. So Nuke, oh no, all right, so, or, okay, so we'll do it this way. This knob is none. All right, so it's the same kind of idea in a fashion. We're saying that if this knob is none, or this knob is one of these things, then do the work. So our guard is a little bit more expansive. We can now get rid of this bit here on the grade. I'll just make it hot again, and then, oops, redefine the function and do some warnings. It's now happy. Because we've said the protection is if you have a knob, then the knob has got to be in one of these names. If you explicitly didn't give me a knob and Nuke hasn't given me a knob, you probably know what you're doing. So if this knob is none, you're good to run. The other way you could look, so that's one way of logic it out. The other way you could logic it out is this way. You could say, if you didn't give me a knob, this will be none here. If Nuke is not going to give you a knob, okay, you could just say, or you could put a default value here of this node.knob multiply, right? Which would have the same rough effect, because you're saying, so for this knob, you either give me a knob, and if you don't give me a knob, you can ask Nuke for a knob. If Nuke doesn't give you a knob, we're just going to say, just it is the multiply knob on this node. So I would probably do, in this case, I'd probably do the other style, because I'm just using the guard to know if I should be running the rest of this code. And one of the reasons I'd want to run the rest of the code is if no knob was supplied and I'm running it in this form. This is a little bit wackier to me, simply because I'm not using this node knob multiply. Like I would, if I was using this form, I would have slightly different code here. I'd be using, instead of requesting the node multiply directly, I'd say the knob value, right? So it would be a form like this. Yeah, okay, so let's do this way. So this knob. Great. So this slight tweak here, right? not a huge tweak, but this slight tweak here has made this function now able to say, if if you do not supply me a knob, it's going to default to saying the multiply knob. If the multiply knob value is greater than 1.2, it will complain it's too hot. But you can tell it any knob you want. So let's do that. So in this case here, multiply is 2.02. Let's chuck that in here. Let's make it not too hot. Right, so it's fine. If I change multiply, great, too hot. Cool. Let's reset that one. So I want to now run it off the knob white. Okay, obviously nothing's too hot here. Doesn't care. It's not saying it's too hot because I've told it, please check the white knob so that way I can gain it here. Right, and now that's too hot. But if I set my multiply down and run that again, it's still too hot because it's looking at the gain knob here, the one that called white for some reason in history. So that is two different ways that you could structure this, and that sort of, I guess, as you get more into this stuff, it's the subtlety of writing these functions. It's why I didn't do it in this case, but I would have recommended writing the doc string here about what you're trying to achieve. As you can see, as I was going through it, there were two approaches I could take. The code for the cases we're in right now would have the same rough result, but when you extend it to this kind of use case here, what you want to achieve from your use case changes how you'd write the subtle differences here. So yeah, hopefully that's been useful. Again, this is potentially a more complex topic than I realized when I started doing these videos. So ask questions, I'll break down these things a bit more. As you can see, someone basically asked me about this one, which is why this video is coming out now. All right, and I guess have fun with it, and I'll talk to you guys later. See you.